Hello, geometors. Welcome to this video. Today we are going to look at inscribed angles and polygons. So let me give you a moment to write down the topic. This is section 10.4 in our book, and we are looking at something called an inscribed angle. So you may want to pause this video while you write these definitions down, and then come back to replay the video, and I will sketch a picture and we can add to these definitions. So I'll read the definitions to you. If you want to pause right now and write them down, you can, and then you can listen to me talk through them. An inscribed angle, it's an angle whose vertex is on a circle and whose sides are chords. So we take a circle. Okay, and the angle is on the circle itself. So your inscribed angle might be like right here. Like I might have a chord going over here and a chord going over here. So that blue angle I just drew is inscribed. Okay, versus a central angle. So a central angle, remember the vertex is in the center. So think the word central sounds like center. So a central angle is where the vertex is at the center. So big difference. Inscribed is on the circle, the vertex. Central angle, the vertex is the center. The intercepted arc is the arc that lies in the interior of an inscribed angle. So on the first picture, the one I drew here, this arc that I'm outlining, hopefully that highlighting is showing up, that's considered the intercepted arc. So if you notice, if you think about these being kind of the endpoints of the arc, so I'm sorry, the endpoints of the angle. So if you were to connect those endpoints with an arc, you have made the intercepted arc. All right, so I will use that terminology as we continue on. Okay, so what properties does an inscribed angle hold? So we have a theorem called the measure of an inscribed angle theorem. So the measure of an inscribed angle is 1/2 the measure of the intercepted arc. Okay, so for example, if this arc over here, if arc AB was 100 degrees, angle D here in the middle is going to be exactly half of that arc. So that means angle D would be 50 degrees. Okay, so the relationship between arc and angle is the angle is half the measure of the arc. Before we go on, to compare that to a central angle. So if I come back over here, if my central angle was 100 degrees, I'm sorry, if the arc here on this circle is 100 degrees, remember the central angle is congruent to that arc. So big difference here. Central angles and our intercepted arcs are congruent. But on an inscribed angle, it's half the amount, okay? Because those two are very easy to mix up. Okay, let's go through some examples here. If you want to pause and try on your own, you can, but I'll just continue to go through this. We're going to use the inscribed angles to find the given measure. So I want to find the measure of arc YZ. Okay, YZ, what I like to do is I like to outline. So I'm going to use a pencil here so I can erase. So if YZ is this arc, I'm going to trace that opening back to the angle. So YZ connects with angle X right here. Now, it also connects over here with angle W, but I don't have any information on it. So if I connect it to angle X right here, if this is 50 degrees, then my arc is twice that amount. So my arc would be 100 degrees. Okay? Now let's find the measure of angle YWZ. So the measure of angle YWZ, okay, that's this angle right here. Okay, well, since it also corresponds to the arc I just calculated, then I can kind of reverse that process and then take half of 100 and call that 50 degrees. Okay. Find the measure of arc WX. So here is arc WX. So I need to trace it back to an inscribed angle. So if I trace it back to angle X right here, that doesn't help me. No, I'm sorry, it does. There's the 35 degree pointing on there. So if I trace it back to angle X, if this angle is 35 degrees, remember that the arc is twice that amount. So I can double 35 and get out to 70. Okay. Finally, angle WZX. So angle WZX is right here. So trace the arc, the intercepted arc. So 70 degrees is the arc. Remember, your inscribed angle here is half of that. So half of 70 is 35 degrees. Okay, so I would recommend you kind of outline your diagrams like that, and then you can kind of figure out what angle they go with. All right, number 2. Find the measure of an intercepted arc. So find the measure of arc RS and the measure of angle STR. What do you notice about these angles? Okay, so let's start with the measure of arc RS. So let me outline RS. So RS goes with angle T over here, but there's no information. RS also goes over here with angle U, and I see 31 degrees. So I'm going to take the angle and double it to get out to the arc. So if I double 31, that gives me 62 degrees. So this one is 62 degrees. In fact, I'll write that on the picture. Find the measure of angle STR. STR. So that's this angle right here. Okay, well, it corresponds to the intercepted arc of 62, so I can just divide by 2 to go back. So now I'm back to 31 degrees. What do you notice? And actually, let's add that to the diagram. Okay, what do you notice about angle SRT, which is 31, and angle RUS, which is also 31? Well, I notice that they are the same. And so you might go one step further and say, well, why are they the same amount? Well, they're both connected to the same intercepted arc. So when they're connected to the same intercepted arc, we're going to divide by 2 to go in. I'm going to say here, they are congruent. Okay. All right, so that idea actually is going to lead us, if you turn the page, to the next theorem. Okay, so keep in mind this visual where they're going to be connected to that same arc. All right, so this theorem is going to restate what we just found. So if 2 inscribed angles of a circle intercept the same arc, then those angles are congruent. Okay, so these angle D right here corresponds to arc AB, okay, because you can just trace that angle opening. And then angle C has the exact same opening, okay? So if it has the exact same angle opening, then therefore it's going to be the exact same measure. Okay, I want you to pause this, and I would like you to run through example 3 and decide which choice is correct. Okay, you should have picked letter C. Okay, so if you go through, and I would probably draw all over this picture because you're trying to identify which angles go with which arcs. So if you look at JKM, okay, goes with arc JM, and then JLM goes with the same arc. So if they go with the same arc, they'll be equal, the angles are going to also be congruent. Angle KJL. So KJL corresponds with this intercepted arc, and then KML again has the same intercepted arc. Okay, so that's how those two go together. Okay, let's go on. We really have one more idea here. Let me give you a couple of diagrams here I would like to define for you. So I want you to draw a triangle in this circle, and I want you to draw a quadrilateral in this circle. So if I draw a triangle, it doesn't really matter, just put 3 dots And then just connect, make your triangle. And do the same thing on a quadrilateral. Of course, I have 4 vertices. Okay, it doesn't really matter exactly where you put them. So I've got 1, 2, 3, 4. So what we just drew here, since we drew a shape in a circle, they're called inscribed. So this is an inscribed triangle. An inscribed triangle. And this is an inscribed quadrilateral. I'm going to run out of paper here. Okay, an inscribed quadrilateral. Okay, so the triangle or the quadrilateral is inside the shape. Inside, think IN, it's inscribed. If you're talking about the circle is going around the outside of the shape, and if you think about going around the outside of a circle, that's called a circumference. So we call the circle circumscribed. Okay, so, and those are some words that we used back when we looked at triangle centers. We looked at the circumcenter, the incenter, and that type of thing. Okay, I'm going to stop this video here because I'm afraid I'm going to get cut off. And then I will start a second video where I will pick up with this theorem here and we'll finish this section.